Good day. The next topic is about proportional integral derivative controller. The next topic is about proportional integral derivative controller, that is called as PID controllers. So PID controllers, generally it has the advantages of both PI and PD controllers. Okay, so we know that PI, you have some kind of stability issues, although we are reducing the steady state error. Okay, in PD, that is proportional derivative controllers, we have what kind of issues? Error issues, although we are concentrating on steady state issues, right? So now both the problems can be overcome by using another new controller which is called as PID controllers. Okay, so here the PID controller can be defined as the combination of proportional integral derivative controller, proportional controller, integral and the derivative controller. So let us see this by writing the equation. So now here u of t, it represents the proportional integral derivative controller, which is directly proportional to error signal and integral of error signal. Also it talks about derivative, right? So that means the third one will be the derivative of the error signal. Simple. Okay, like what we are doing, we are combining the error signal with the integral of error signal and the derivative of the error signal, that is proportional integral derivative controller, right? You can also write here where u of t is what? It is the error signal. Okay, integral of e of t is what? That is what? Integral error signal, right? And derivative d by dt of e of t is equal to what? It is the derivative error signal. Okay. So now we are supposed to remove this proportionality symbol by introducing the constants, right? So therefore, the above equation becomes u of t is equal to, introduce the constants, k of e of t plus k of what? Integral of e of t plus k dot derivative d by dt of e of t. In order to differentiate the constants, we are supposed to introduce proportionality by kp. Then for integral, it is what? Ki, and for derivative, it is kd, as what we have discussed in the previous controllers, right? So kp is what? Kp is the proportional constant, ki is the integral constant, and kd is the derivative constant. I think I don't want to write this constants one more time, since I have written in the before controllers when I'm explaining the previous controllers. Okay, so you know the equation u of t is equal to kp dot e of t plus ki dot integral of e of t plus kd of d by dt of e of t, right? So now in order to find the transfer function, we are supposed to convert the time domains into frequency domain. So for that, we are supposed to take Laplace transform on both sides, right? LT of u of t into LT of the same equation, kp dot e of t plus ki dot integral of e of t plus kd dot d by dt of e of t. Okay. So when you take the Laplace transform, the time domain becomes frequency domain, so that you can write the above equation as therefore u of s is equal to, just apply the Laplace transform for the signals. That means constant is still the same, kp dot e of s plus ki of, from the formula of Laplace transform for integration, we know that Laplace transform of integral e of t is what? That is e of s divided by s plus kd dot Laplace transform for d by dt of e of t is what? From the formula, it is s times e of s. Okay. So just remember the Laplace transforms for the integration symbol. Integral e of t, it becomes what? E of s divided by s. Good. Then Laplace transform of d by dt of e of t becomes what? It becomes s times e of s. Okay. The only thing for you to remember under these three types of controllers, it's very important for you to remember the formulas of Laplace transform. Integral of e of t and d by dt of e of t. Okay. So from the above equation, you can take e of s outside. That means it becomes e of s of, what are the terms? Kp plus ki by s plus kd dot s, right? So the gain can be written as, for us to obtain the gain, we are supposed to write this e of s to the left hand side. So e of s divided by e of s is equal to, that is the gain, which is equal to kp plus ki by s plus s times kd, right? In order to get our normal arrangement, we are supposed to take kp outside. So when you consider kp outside, that means you can write as kp of 1 plus ki divided by s times kp plus s times kd divided by kp. Okay. So for your understanding, let me use like this. When you multiply, what happens? You're supposed to get the same equation. That's what, when you multiply, this becomes what? It becomes kp, right? When you multiply here inside, it becomes dot, what is it? Kp, right? When you multiply with the third term, it also comes with kp, right? So you can cancel kp and kp here, kp and kp here, so that you will be getting the same equation. Just take the equations kp plus ki by s plus ks dot kd, right? So for us to obtain like this, we are using this kind of arrangement. What arrangement? 1 plus the other following terms. Okay. Okay. So now you can close the bracket. So now you apply PI. So you all know that PI is what? PI. Okay. PI is equal to KP by KI, or you can write as 1 by Ti is equal to KI divided by KP, right? So replace Ki by Kp as what? 1 by Ti and KD by KP as PD, right? So the previous equation, it becomes U of S divided by E of S is equal to Kp of 1 plus 1 divided by Ti dot S plus Td dot S, right? This is your transfer function you're going to write here, right? So the PID controllers output is what? It is nothing but Kp of 1 plus 1 by Ti dot S plus TdS. Okay. So which is the combination of the error signal, which is what? From the PID controller, which is written as U of S. Okay. So this is going to be the combination of both the integral and derivative controllers. Okay. So these are the three types of controllers, and we are uh, supposed to find the transfer function of three controllers. It is very important. So all those three transfer functions from the PID controllers are going to be the outputs of each controllers: proportional, integral, and derivative controller. So now let us summarize all the controllers. First, we were learning about PI controller. PI controller is what it is. U of t, that is PI controller, is directly proportional to the error signal, also the integral of error signal, right? Then we learnt about PD controller, which are directly proportional to the error signal and derivative of error signal. Then we learnt about PID controllers, where U of t is directly proportional to the error signal plus integral of E of t and derivative of E of t. Right? Next important thing is we are supposed to learn the two Laplace transform formulas, right? So what are the formulas we applied? They are Laplace transform of integral E of t is equal to E of S divided by S. This is one formula. Then Laplace transform of d by dt of E of t is equal to S times E of S. These both are obtained by using the Laplace transform. Why we are supposed to obtain the Laplace transform? We are supposed to find the transfer function, right? In order to find the transfer function, we are supposed to convert all the time domain signals into frequency domain. So also there is another important thing for you to summarize. It is about TI and TD, right? So Ti is what? It is total constant, integrity constant. Ti is equal to what? Ti is equal to Kp divided by Ki, right? And Td is equal to Kd by Kp. Okay. So if you know all these things, you can derive the equations for all the controllers, three types of controllers. Okay.